Welcome to week 9. Last week during week 8, we watched a lecture and a sit-down discussion with the author, Paul Hawken, of the book Drawdown, the most comprehensive plan ever proposed to reverse global warming. Today's lecture is all about air quality, and I wanted to start off with this image of Mount Vesuvius in Naples, Italy. You might think that this is extremely picturesque and beautiful to see on your vacation, perhaps, maybe that we can all one day take very soon, fingers crossed. But what's striking about this image is that it highlights the dense fog that is preventing a clear view of Mount Vesuvius. This is a special type of fog that we'll get into the specifics of, but it is called smog, and it's actually more prevalent worldwide than you might think. So this is all about air pollution and health and the intersection between air pollution and human health. So air pollution in and of itself involves a couple of things. All of them are particulates in the air. This includes smoke, haze, dust, odors, corrosive gases, toxic compounds, particulates. All of those things together comprise what we know as air pollution. And these pollutants, they cause a number of different bad things to our bodies, including irritating our eyes and our lungs. These pollutants can also enter our bloodstream when we breathe them in. So it's not just impacting our lungs, it also gets into our bloodstream. When it gets into our bloodstream, there's a real potential to cause perhaps permanent damage in the way of damaging nerves and even brain function. The Organization for Economic Cooperation and Development says that by the year 2050, chronic exposure to pollution will cause 3.6 million premature deaths each and every year. And in Europe, keeping in mind the image that we just saw in Italy, in 2012, air pollution caused about 85,000 premature deaths in Italy. That is the highest among any of the European Union states, and that's according to a latest report from the European Environmental Agency. That same agency said that the air quality in Europe, specifically in Italy, is still the single largest environmental health risk to those individuals. And in Europe alone, that is estimated to cause about nearly 500,000 premature deaths in 2012 across 40 countries that they collected data for. So air pollution is the single largest environmental health risk in Europe right now. But what about the United States? So we do have a number of measures here in the US to reduce the amount of air pollution that we encounter on a day-to-day basis. These include things that were enacted as part of the Clean Air Act, which was put forward and passed to regulate major pollutants. So the Clean Air Act of 1970 designated new air quality standards to be applied equally across the country for 6 major pollutants. And they defined these 6 major pollutants as conventional or criteria pollutants. In other words, these are the major ones that are monitored and data is reported out for. So the first is sulfur dioxide. The second is nitrogen oxides. Number 3 is carbon monoxide. Number 4 is ozone. Number 5 is lead. And then finally, we have particulate matter. And we'll get into each of those in the coming slides. But for now, let's keep a broad overview on what the Clean Air Act does. So the National Ambient Air Quality Standards that were designed as part of the Clean Air Act designated allowable levels for these 6 major pollutants. These major pollutants are output mainly through transportation and power plants. So these are the dominant sources of those criteria pollutants on the previous slide. And power plants are industrial plants that convert mechanical energy into electrical energy that can then be sent to the electrical grid for us to use in our homes and other infrastructure. So here I have an image of the Kingston coal-fired power plant that is ran by the Tennessee Valley Authority. It is located in Kingston, Tennessee. And this plant has 9 units that can generate approximately 10 billion kilowatt hours a year. And that's enough electricity to power approximately 700,000 homes. So to meet that energy demand, this plant burns about 14,000 tons of coal each and every day. That amount of coal would fill 140 railroad cars. Now, I did a little bit of research on the type of coal that is used at the Kingston fossil plant, and their website says that this plant burns a low sulfur blend of coal in order to limit the emissions of sulfur dioxide that we just discussed was one of those constituent pollutants. Other emissions reducing features at the plant include the installation of selective catalytic reduction systems, and this can reduce the nitrogen oxide emissions by about 90%. In addition to that, they also have 2 scrubbers, which can reduce sulfur dioxide emissions by 95%. So looking at the different sectors that contribute to these conventional major pollutants, we have the 6 ones laid out here, and then the different sources for those pollutants. So just take some time and look over these different anthropogenic sources of those 6 primary criteria air pollutants. Now let's get into unconventional pollutants. Those 6 are what we call criteria or conventional. In addition, we also have unconventional. So these unconventional pollutants are compounds that are produced in less volume than those conventional pollutants, but they are still especially toxic or hazardous, especially when we're talking about human and ecosystem health. So examples of these unconventional pollutants include things like asbestos, benzene or beryllium, mercury, these polychlorinated biphenyls or PCBs for short, and vinyl chloride. In 2009, the EPA, the Environmental Protection Agency, announced adding carbon dioxide and other greenhouse gases to its list of regulated pollutants. So this decision actually still remains controversial. So the question that we need to ask, now that we understand the different sectors that are responsible for emanating these different conventional pollutants, how do we define pollution sources? That's a different question. So many pollutants come from what we call a point source, things that form a concentrated pollution origin. A quick example is a smokestack. So for example, here we have smokestacks that are the point source for those conventional and unconventional pollutants. Primary pollutants are substances that are harmful when they're released. So immediately upon emission, they are harmful. Secondary pollutants, on the other hand, become harmful only after they react with other gases in the atmosphere or other substances in the air. So they're not immediately harmful upon emission. And then finally, we have what we call fugitive or non-point source emissions. These are those that don't go through a smokestack. So examples include leaking valves and pipe joints, leaking out things that aren't supposed to get out, but they do anyway. So these fugitive or non-point sources contribute about 90% of the hydrocarbons and volatile organic chemicals that we have at our chemical plants and our oil refineries. They're becoming increasingly a problem with our natural gas wells, and dust such as mining dust or agriculturally related dust and binding construction and demolition, all of those as well are considered fugitive emissions. So many of our most serious pollutants are fugitive emissions from specifically petrochemical facilities. An example of a petrochemical facility is this one pictured here. This one is located in Baton Rouge, Louisiana, and it's actually the 5th largest oil refinery in the United States and the 13th largest in the world. It has a massive input capacity of over 500,000 barrels per day as of 2018. So here's just an extreme example of one of those petrochemical facilities that's responsible for pumping out both primary pollutants and those fugitive emissions. Now, you might be asking yourself, Baton Rouge, Louisiana, isn't that a highly populated place in Louisiana? Why are all these smokestacks just in the middle of neighborhoods that can't be safe? And you're right, it's definitely not. Actually, these petrochemical plants inhabit a location in Baton Rouge that is colloquially called Cancer Alley. It got this moniker in the late 80s when residents of one street in particular in St. Gabriel, Louisiana, noticed that there's high cases of cancer within their community, high cases of respiratory distress and disease. This is also a primarily African-American and low-income neighborhood. And they started scratching their heads about this and wondering, why is there such a greater instance of these diseases and morbidities here? And so eventually this place became known as Cancer Alley. It became the new name for not only that particular street, but about an 85-mile stretch of road in Baton Rouge, Louisiana. As similar incidences became more and more prevalent in the surrounding areas, that alley grew to encompass 85 miles along the Mississippi River. So it quickly became apparent that it wasn't a highly localized problem. It was actually much more prevalent than anyone had thought. In 2002, Louisiana had the second highest death rate from cancer in the entire country. While the national average is about 206 deaths per 100,000, Louisiana's rate was about 237.3 deaths per 100,000. And that's really due to the prevalence in Cancer Alley. And I'd like you to I'd like you to watch this YouTube video that I've posted to the Tartan that talks about Cancer Alley and its historical context, and now pushing forward to understanding why people in that region, in Cancer Alley, are more susceptible to dying from COVID-19 right now. And I should also mention that Cancer Alley is home to a number of successful community organizations that are grassroots organizations that have been fighting against new factories being built in their communities since the 1970s. So now let's get back to discussing in more detail those conventional pollutants. We understand that they are abundant and they are serious because of the massive detriment to the health of the ecosystem as well as human communities that they pose. So the first one is sulfur dioxide, or SO2. It is a colorless, corrosive gas that can damage both plants and animals. Once SO2, sulfur dioxide, is in the atmosphere, it reacts with water vapor to form an acid called sulfuric acid, and the formula for it is right here. Sulfates in general can reduce visibility up to 80%. So these will contribute to that smog that we were talking about at the top of the lecture. In addition, the second one are called nitrogen oxides. And the notation for these nitrogen oxides is NOx. These nitrogen oxides are formed when the heat of combustion initiates reactions between atmospheric nitrogen, which is inert. Here we have N2. So reactions between atmospheric nitrogen and oxygen, O2. So during combustion, for example, in a combustion engine, like in our cars, that initiates that reaction between atmospheric oxygen and atmospheric nitrogen. We get that initial product of nitric oxide, which is NO. That nitric oxide will oxidize further in the atmosphere to turn into nitrogen dioxide, which is NO2. And NO2 is a reddish brown gas, which will give smog its distinctive color. So that smog that you see in heavily populated urban areas is largely reddish brown because of nitrogen dioxide. We also have carbon monoxide. Carbon monoxide is a less common, but it's more dangerous than the principal form of atmospheric carbon, which is CO2. CO, carbon monoxide, is colorless, odorless, but it's highly toxic, and it is a gas. It's produced mainly by the incomplete combustion of fuel, including things like coal or charcoal or wood. Carbon monoxide is extremely dangerous because it inhibits respiration in animals. And it does this because it binds very, very strongly and irreversibly to hemoglobin in your blood. And hemoglobin is what carries oxygen throughout your body. In the United States, about 2/3 of the carbon monoxide emissions are created by internal combustion engines in transportation. We also have land clearing fires and cooking fires as major sources as well. And about 90% of the carbon monoxide in air is consumed in photochemical reactions that produce ozone. So that brings us to ozone. We've talked about ozone before because of its importance in the upper atmosphere, where it shields us against UV radiation from the sun. We talked about that in the climate chapter, but it actually is pretty damaging to humans at the ground level. That's because ground level ozone is a highly reactive oxidizing agent that can damage our eyes, our lungs, even plant tissues, as well as stripping paint and rubber and plastics. We consider ground level ozone as a secondary pollutant because it's created through chemical reactions that are initiated by solar energy. So it's not a primary pollutant. Instead, it's a secondary pollutant that's formed by a combination of chemical reactions initiated by the sun. In general, pollutants created by these light-initiated reactions are known as photochemical oxidants, that is, oxidizing agents that irritate tissues and damage materials. And when you create them through interactions with sunlight, they're called photochemical. One of the most important of these reactions involves the formation of single atoms of oxygen by splitting nitrogen dioxide. We're going to talk about how ground level ozone is created on the next slide. So we know that ozone is a secondary pollutant that can be created through photochemical reactions, but it also can in part be created through interactions with these volatile organic compounds that can contribute to the formation as well. So let's synthesize all of that into a diagram. Here we have a diagram that is depicting the different ways to make ozone at the ground level. We have fuel combustion happening in tailpipes of cars all of the time. This causes nitric oxides to form when they come into contact with atmospheric nitrogen and oxygen. So the molecule NO is going to react with oxygen to form NO2. This molecule of NO2 will then react with water that's in the atmosphere, H2O. They'll combine to create nitric acid, which is HNO3. This nitric acid can be dissolved in water, like rain, and create acid rain. In addition, we also have solar radiation that can force NO2 to release a free oxygen. Now that free oxygen that came from NO2 can then join up with a diatomic oxygen molecule, which is just two oxygens stuck together. The joining there creates ozone, which is three oxygens stuck together, O3. Fuel combustion also produces incompletely burned hydrocarbons, and we call these volatile organic compounds. The one depicted here is benzene, which is a ring of 6 carbon atoms and a hydrogen atom attached to each carbon. Both ozone and the VOCs contribute to photochemical oxidants in reactions that are activated by sunlight. So getting back to our list of conventional pollutants, number 5 is lead. Lead is our most abundantly produced metal air pollutant, and it is so important to understand the impact of lead because it impairs nerve and brain functions. It also can interfere with the development of a brain, and it does this by binding to essential enzymes and cellular components and, in effect, disabling those components. Lead, unfortunately, is produced by a wide range of industrial and mining processes, especially smelting of metal ores and mining and burning of coal and municipal waste. All of these lead to trace amounts of lead in the atmosphere. Now, even trace amounts of lead can prove especially damaging, especially to those vulnerable populations who are developing and are children or fetuses. Now, historically, lead has been a problem in the burning of gasoline, but fortunately, lead in the United States since about the 1980s has been mandated to not include lead. So since 1986, there was a ban put in place on leaded gasoline. And when this ban was enforced, children's average blood lead levels dropped about 90%. And it wasn't just a drop in the lead levels, it was also a simultaneous increase in average child IQ, rising about 3 points. That shows a direct link between lead poisoning and brain development. So banning leaded gasoline in the United States was one of the most successful pollution control measures in American history. Now, 50 nations across the globe have renounced leaded gasoline, and the global economic benefit of this step alone is estimated to be more than $200 billion a year. So the impact of lead on communities of color is especially laid out in A Terrible Thing to Waste, Environmental Racism and Its Assault on the American Mind, written by Harriet A. Washington. There is a upcoming homework assignment that's actually due in April about this, where you will be doing some reading. So if you have time before it's actually assigned, I highly recommend that you begin that assignment. It is really interesting and important to understand. Number 6 is particulate material. Particulate material includes dust, ash, soot, lint, cigarette smoke. It also includes things that you really might not think are that bad, like pollen or spores or algal cells, even biological materials. Anything that can be aerosolized or thrown up into the air and potentially inhaled is particulate matter. So aerosols, or extremely minute particles or liquid droplets suspended in the air, are included in this class of particulate materials. Particulates often are the most apparent form of air pollution since, of course, they can reduce visibility and leave dirty deposits on windows, textiles, or painted surfaces. Breathable particles that are smaller than 2.5 micrometers are among the most dangerous of this group because they can damage lung tissues. This includes asbestos fibers and cigarette smoke. These are actually the most dangerous respirable particles in urban and indoor air because they are carcinogenic. In other words, they can cause cancer.